Hey, hi, welcome back to SGLang Office Hour. So today we have a special episode since DeepSeek-V4 is a very important model, not just say for us at SGLang, but also for many people in the industry. And before we get started, so we had Cheng and Yueming from SGLang and the Miles team. Cheng, can you give us a quick intro of yourself and for us, and maybe talk about like, how you're getting to SGLang, what you have been working with SGLang, stuff like that.
Hi everyone. My name is Chen, and I'm currently working for Inference, and my major task is to improve or maintain SGLang. And I've been joining the SGLang community for 1 year, and my major focus is actor parallelism, MOE refactor, and DPO attention. I did a lot of work in improving or developing some parallelism features in SGLang. And I also maintained the CI container last year, and I just joined the company already last week. So I'm still a new joiner of this company.
Amazing. How about Yueming? Love to hear your story.
Yeah, hello everyone. I'm Yueming, and I'm a member of SGLang RL community. So now I'm developing Miles, also at DeepSeek. I joined SGLang community maybe like in the last year. So before that, I was working on the training infra, and when SGLang RL grows fast, I joined it and help everyone to build the RL framework.
Oh, great. Yueming, can you tell us what is Miles? Because I mean, the audience here, they probably already know about SGLang, but how about Miles? What is Miles?
Sure. Miles is an RL framework and natively developed with SGLang, which means it only uses SGLang as an inference engine and mainly use Megatron as the training engine. So yeah, we develop many of the RL features together with SGLang and Miles.
Amazing. So yeah, we can get into the topic right now. So SGLang have the day one support, not just for fast inference, but also we have a verified IO support as well. I think so Cheng, you have the stage. You can walk through how does SGLang support DeepSeek-V4, and also what's the story and technical detail behind that. Oh, Cheng, I think you're muted. Could you? Yeah.
Okay. Yeah. Okay. So let me take a quick look of our major features that were supported from Day-0 in SGLang. SGLang has a lot of fancy features like PD desegregation, high cache, Radix cache, and hybrid parallelism. And all these features are supported for DeepSeek-V4 from Day-0. And here we also provide hybrid or comprehensive features for IR training, like for parallelism, time-long attention, enhanced stability, and MBA training. And our SGLang also supports various hardware like Hopper, backware, and Grace backware. And here in this QR code, you can find the best recipe for different hardware, different model variant, and different serving objects in your environment. For example, if you want to serve your Pro model on B200 and you want to maximize throughput, you can try using this launching command. That would maximize the throughput for your serving. And next, let me briefly introduce some new features developed by DeepSeek, and that's why supporting DeepSeek V4 inference is very challenging. In V4, they have a hybrid attention mechanism. In each layer, there are two kinds of attention. One is slightly mingle attention, and the other one computes attention over a compressed state. For slight window attention, this is a widely used technique. We have it in GPT-OSS. It's attention only use the latest several tokens. And for the compressed part, this is the new part developed by the DeepSeek team. For each layer, it has two types of attention. One is, it has either compressed force attention or compressed 128 attention. For C4 part, we use sparse attention, which means we do not use all tokens. We only select the top K tokens, and we use these K tokens for computing attention. And for the C128 part, it is a kind of full attention over the compressed dimension. So this is the framework of DeepSeek attention. Each layer has two types of attention, and each layer has either C4 sparse or C128 depth. And in addition to these three types of attention states, we also need to maintain in-flight tokens for computing C4 sparse or C128 dense states. So in our KV cache, we have 5 types of attention states in total. And this provides a very challenging, this is a very challenging task for us to develop a hybrid KV cache. And it also brings more challenges for supporting other features like PD disaggregation or Redis cache. And to handle such a complicated attention design, we need some abstraction because we want to ensure that the code for PD disaggregation and Redis cache is not messy. And this is what we proposed. It's ShadowRadix storage layout. We provide one abstraction layer and from different upstream features, they just need to ask this layer which token it wants to fetch, and then this abstract layer would forward this request to the actual physical memory. For example, if this layer requires C4 attention pool, it would go through this shadow B part. And for each layer, they definitely need the sliding window pool. And for the in-flight tokens part, we use a ring buffer because its size for each request is static. We use a ring buffer to ensure that we do not need to occupy extra memory for this feature. And in addition to our layer of storage design, we also needed to develop some efficient kernels to optimize this attention. For example, in DeepSeek-V4, we have some compressed states. And if we implement this compression in a naive way, we need multiple HBM access for different stages. The first stage is to compute some bias over the original KV cache, and then we compute softmax and use scale dot product. And if we compute each of these operations sequentially, we need 5 HBM access in total, which is pretty slow in GPU because all compute units are waiting for memory access. And here we developed a fused kernel. Basically, we fuse the intermediate 3 kernels into one kernel. And we only need 2 HBM access, that is with KB loading and storing the complex states. And this can reduce HBM round trips from 5 to 2. And also we observed that the computation for long context, or attention computation for long context is very expensive. And after we did some profiling, we observed that its top K kernel was pretty slow. That's because the torch kernel for top K cannot fully leverage computation resources. So here we develop a new top K kernels named the Lightning top K. It computes top K from a different direction to maximize parallelism. And based on our analysis for long context serving, the top K kernel was reduced from 100 microseconds to 15 microseconds. So it's about 5x speed up. Okay, and the next part is parallelism. So previously we discussed KB cache and kernel optimization. And the supporting hybrid parallelism is another challenge because for DeepSeek-V4, we need some dedicated kernels, but these kernels need some assumption for the input tensor shape. So if we use tensor parallelism, we have to shard the computation along head dimension, and this would violate the kernel assumption. So here we in SGLang we developed some padding technique to ensure that the local head on each device is a multiple of 64. And we also support context parallelism for non-context parallelism, non-context inference, and expert parallelism for large-scale inference serving. And SGLang also supports page-to-KB transfer for PD disaggregation. And SGLang also supports hierarchical multi-stream overlap. Because we observed that when we compute this complicated attention mechanism, this computation has a lot of small kernels, which waste a lot of computation resources in the most advanced NVIDIA GPUs. So we need some kinds of overlap. But these streams also have some dependency. So we need to carefully develop our overlap strategy to make sure that the kernel works well. We can still ensure that the dependency is never broken. For example, when we compute this Q LoRa part, this QA, which is the LoRa projection. So the pre-processing stage of LoRa stage, it needs to be computed first before computing Q projection. And then after this stage, we can compute QB and Q projection at the same time. So we spend a lot of time in finding the best overlapping strategy for this complicated kernel. Okay, and that's all for our support in SGLang. Okay.
The R support.
Okay, yeah. From now, I will introduce our Day-0 IO support for DeepSeek-V4. So people may be wondering that why Day-0 training support is very rare. Actually, this is because for training, you are not only required to implement the forward pass of the model, you also need to do everything for the backward pass. And one of the hardest reason is it's very hard to verify the correctness of your training framework. So maybe you can randomly write a DeepSeek-V4 model, but how can you make sure your training is actually working? Because every training run may take even 1 day or multiple days. So especially for DeepSeek-V4, this is a very complex model. It has many novelties in their model architecture. So even supporting the inference engine has been already very hard. But our team managed to support the Day-0 training, enable the RL in Miles using the fast SGLang inference engine and our customized training backends. Now I will try to cover some of the technical details and what we did for this part. Okay, so you can look at this figure, but I will try to introduce on my own. First is our first effort is on the training backend, which means we implement the DeepSeek-V4 modeling using the Megatron LMs format. So for DeepSeek-V4, most of the ops, for example, the compressor attention, the compressor and the indexer and the MHC, all of those ops are rebuilt because of their new model architecture. So this brings a lot of complexity to the training backends. And many of them are not natively supported by Megatron, but we did that in our Miles. We support all the 6 kind of parallelisms in Megatron, including DP, TP, SP, EP, PP, and CP. So for TP and SP, they're relatively easy because we can use the primitives and just to make sure it is correct across the compressor tension. And for PP, we might need to slightly modify the Megatron's PP engine because we are using MHC, so the dimension is kind of different from other models. And for CP, this part is the hardest. And if you look at the DeepSeek-V4's technical report, they implement CP in ring style, and they mention that because of the compressor, you might need to do some extra processing of each CP slice. So you might need some adjacent information and not only the information for the current slice. So in our implementation, we do it in an all-gather way. For the compressor, we will all-gather the activation at the so for the overlapped transforming, we will do an extra all-gather to make sure the transforming is calculated correctly. As for the kernel part, we implement the SGLang's we implement the SGLang kernels for the DeepSeek-V4. This part is adopted from the previous SGLang kernels for JRM5 with some new things like the attention sync. So this includes the sparse MLA, which has per-head learnable attention sync logics in the softmax, and also includes the DSA indexer kernel. For the MHC part, we use the fused SGLang sync home kernel for the forward pass. After the initial PR has been released, we'll also already do some extra work in the enhanced kernels, like we integrated the tile kernels from DeepSeek official. So there will be some follow-up PRs in Miles. And for the other IO features, first is the training precision. We try to support the IP8 rollout and IP8 and BF16 training in our engine. For this part, we implement the quantization processor in the weight update engine of Miles. So you can combine with different rollout predictions and training predictions. We've already been developing the IP4 rollout and the entire IP4 training recipe in Miles. We also developed the rollout routing replay and the indexer replay in the whole system. For rollout routing replay is already a feature in Miles. We extend it to a new data format that adapt to the backend we use for DeepSeek-V4. And for indexer rollout, it's specific for the DSA attention. So we apply the similar techniques as routing replay in MOE. We record the routing result from the DXA indexer and replay it in the Megatron training backend. Besides of this, there are many small IO features. We all try to enable and verify it in the real training, such as the TIS, MIS importance sampling, and FP8 attention QAT. You can see the details of those features in our repo. So across our entire supporting, we're always trying to keep a high numerical precision for the training part. So actually, to support the IP32 mixed precision in Megatron, we have to do a lot of precision fixes. For example, in the attention backend, we need to adjust the gradient. We need to adjust the precision of the gradient for the KV tensor. And in the optimizers, we need to carefully deal with the situation that some of the parameters have native IP32 precision, but those cases are not already supported in Megatron. So we also explored a lot of the deterministic techniques, such as the QDN backends and the deterministic communications, like the ring-style NICO and the transformer engines deterministic options. We enable those deterministic techniques to reduce the random numerical spikes in the training dynamics, such as scale loss. So the figure I showed in the slides is our training result on DAPO dataset, which is for the Flash model to 85 billion parameters. You can see that the reward is growing across the 80 steps, and the evaluation score is also growing fast. So we also observe the log probability across the entire process. At the beginning stage, it's like 0.02 to 0.03, relatively low level of these sizes of models. And after the 80 steps, it can grow to like 0.05. So in the recent days, we also have another achievement that we've already developed the training recipe for the 1.6 trillion largest pro model. Now you can launch this largest model training on 256 H200 GPUs just in one command. So we included all of our technical details in this LMC's blog. This includes both of our inference optimizations and our RL development. You can scan the QR code on this page to read this blog. And in this page, we pasted the recipes and cookbooks for our systems. The first QR code is the SGLang cookbook. You can find the best configs and commands for your hardware and workload to deploy DeepSeek-V4 on your own machines. And the second QR code is our SGLang DeepSeek-V4 roadmap. You can see the development progress and our future plans on this model. And the third QR code is our Miles DeepSeek-V4 roadmap and recipe. we will show the training recipe of both Flash model and the Pro model in this page.
Okay, this is good. I think now we can do Q&A section. I think we already have some comment here. Yeah, let's see. So we have Paul asking, had you test throughput and recipe for using a tool MVL72? Thanks. I think this question is for Cheng, right?
Yeah. So I guess you're asking the throughput under PD desegregation, because otherwise we do not need to use a full tray of GP200 or 300, GP300. So under PD desegregation, according to our latest experiments, the prefill throughput can achieve 13K per GPU. And on the decoder side, the peak throughput is around 8,000. But we believe we can further improve its throughput because so this benchmark is based on 8K input. So it purely depends on your workload. If your input length is much smaller, I guess we can achieve maybe 10,000 K throughput in each decode device.
Great. We also have Frank from YouTube asking for DeepSeek MOE mega kernel. Is there any discussion about Hopper support? Thanks.
I have not. We have not considered developing the mega kernel to DeepSeek-V4, but on Hopper nodes, our current major focus is GB. But we can definitely consider extending its support to Hopper.
I think we need to wait for more comment from the community. So feel free to share if you have any question for the DeepSeek support and also for the Miles support. Before we get more question, I also have a question. So what's currently on the roadmap like for SGLang right now in terms of DeepSeek support? Cheng, can you share about that?
Our current roadmap. So one ongoing effort is to merge it to the latest vein. Yeah, there are still maybe thousands of lines of conflicts. So we need, our colleague is spending a huge effort in making it compatible to the latest vein. And we also need some code refactor efforts because the current code, I have to say it's acceptable, but we have some better way to make our code structure cleaner and scalable. So basically, there are the ongoing efforts of rebasing this branch domain and doing some refactor. We also have some optimization ideas, but we do not foresee that these features can bring huge improvement. The major features has been supported on the our DeepSeek-V4 branch.
Is there any feature size items on the roadmap, like supporting SM120 or supporting more hardware like AMD or other NPU stuff?
Oh yes, for different devices, yes, we have a lot of collaborators. Like if you open the SGLang pull request, you can see a bunch of PRs that want to support DeepSeek-V4 on different devices like AMD devices or NPU devices. So, our major focus is GB, and we have other collaborators or the open source communities is trying to support it on other hardwares.
This is great. How about Miles? What's some Roman items miles right now for DeepSeek IO support?
Yeah, sure. So our first priority is definitely to get a growing reward curve for the 1.6 trillion Pro model. So now we have the training recipe, the usable Docker and large command, but we need some time to do a really large scale test on some real training data. And for the features wide, there's a lot of newly released features in the DeepSeek-V4 technical support. So we are very excited to implement those. For example, the IP4 training recipe and some of the new RL frameworks designs, like the OPD and the agent framework. We will extend our infra to a wider scale.
I see. I see. We have a question from Slack community, asking, do we have a recipe for, doing RL for DeepSeek-V4? Are you going to post a blog about that? Do we have that on plan or?
For the recipe, do you mean how to run the system or how to train the model and to make the best accuracy?
My understanding is I probably have something like a notebook, or you can do that step by step. Stuff
yeah, we will release the recipe in our roadmap, it's GitHub issue, so you can look at the last page of the slides. Yeah, so the third QR code, this usually will contain the nearest recipe to run the system.
Okay, we have new comments from YouTube. In SGLang's Day-0 implementation, what's the dominant bottleneck across the 4K to 1M token range, kernel fusion efficiency, KV cache bandwidth, schedule overhead, and attention path routing? There's a lot of things. And how did you verify the observed throughput curve is architecture limited rather than implementation limited? This is a very long and good question. I think this is for Cheng.
Just give me some seconds to read the question. Okay.
Yes, let's read the question again. So in SGLang's Day-0 implementation, what's the dominant bottlenecks across the 4K to 1 million token range? There's a lot of technical terms here. Yeah. And the second line. Yeah. And how did you verify that the observed throughput curve is architect limited rather than implementation limited?
It's a very complicated question. So I feel that based on our benchmark for the non-context serving scenario, attention is always the major bottleneck. And we identified that there are a lot of kernels that need to be optimized, like compressing the attention states, because DeepSeek-V4 developed a compressed attention mechanism, and the top K kernel also needs to be optimized because for long context, like if the input has millions of inputs, we need some kernel optimization for the top K kernel. So it's hard to say which one is the major or dominant bottleneck. We just feel that the kernel itself is very complicated, and it has maybe more than 10 kernels need to be optimized, and we need to consider how to. Yes, we developed some fusion techniques, and we also improved some kernel itself, and we also developed considered multi-stream launch to better utilize the kernel or resource utilization. So I hope this answers your first question. There are a lot of aspects we need to consider or optimize. And for your second part, how did we verify that the observed throughput curve is architecture limited rather than implementation limited? We just, because for different architecture, it has a roofline curve, right? We need to compare the, so whether the implementation is memory bounded or computation bounded. And for long context serving, the attack mechanism is always memory bounded. So here we just measure whether we fully, we just compare our measured bandwidth with the bandwidth reported by the hardware report. And then we can confirm whether it is architecture limited or implementation limited.
Okay, we are moving on to the next question. So had SGLang plus DeepSeek-V4 Pro been successfully deployed on a 2-node H200 with real isolated subnets? Also, I think this question is for Cheng, right?
So what is real isolated subnets? Could you please provide more explanation?
Okay, I think we can move on to the next question. We'll wait until the classification of the question.
Yeah.
So we have Hai Wu from YouTube asking, is the cookbook doc wrong for H200 deployment? It has a command line, blah, blah, but also for 200 GPU, use SGLang checkpoint on the SGL project.
It's correct, because for H200 deployment, we use 88 quantization, but the official checkpoint from DeepSeek is NVIP4. So here the SGLang team traverse that checkpoint into FE8 format, and we maintain it in our SGLang repo.
Okay, before we get more comments, I would love to know, like, did you actually try to use a DeepSeek-V4 on your daily workflow? Like, are you trying to use that for code or do any writing? I would love to know, like, what's your current, like, any experience with the model? I think Yueming, you can go first, and then we can, if I can.
I haven't used DeepSeek-V4 for my own task, but I see many people in the social network is using it, and yeah.
I see. How about Cheng? Had you used us so far?
I'm not sure, because for my coding agent, I don't know which model it was automatically selected. Maybe it's sometimes pick DeepSeek-V4 for A/B tests, but it's out of my awareness.
I they use DeepSeek to do some translating and also like writing work. It's a very good. It's a very knowledgeable model. Thank you for the video. I mean, I also have a personal question to Yueming. So, like, if someone, like, let's say, like a company, they would like to like fine tune DeepSeek from the business with it, like domain data, also proprietary data. So, what kind of like thing they would need to prepare? Like, do they need to prepare the data? What kind of infrastructure do you require to actually fine tune the DeepSeek-V4 for them?
Okay, so if they want to fine tune the DeepSeek, I think there's no big difference from other models. I think they only need to prepare their data and make sure it is difficult enough, so the DeepSeek model cannot solve it at the beginning. And for the infra part, I think we will provide the full pipeline open source, so don't need to do too much.
I see. Like, how many data we're talking about? Like, I say it's going to be like hard question. It's going to be like something like like require a lot of thinking and stuff like that, or even like domain focused kind of a question. But like, how many data we're talking about here, like to do the fine tune?
I think it depends on the task, the difficulties. For example, if you're doing something like the coding, it would be relatively harder, and maybe if you just want the model to learn some format or some like the regular patterns, it will be much easier.
That's awesome. Oh, we have the follow-up from YouTube. We can go with the latest one. Yes. So the rail isolated means each node's NICs on a given rail is its own separated 31 subnet, rather than sharing a subnet with the corresponding NIC on the other node.
I have to say, it's out of my knowledge. I'm not sure whether we have some dedicated optimization for this architecture.
I mean, like, you're welcome to like raise any issue on SGLang GitHub, and also like welcome to join our Slack community. So maybe we have like someone in the community can answer a question.
Yes, and you can also join SGLang Slack.
Yes, we have one more question from Paul at YouTube. Yueming, do you think there exists novel optimization opportunity for tuning RL on the multi 100K context range?
Okay, this is a very good question. So you mean the novel optimization opportunities? So I think first is we need to focus on the context parallel. I think the current context parallel in our implementation has a large optimization space. For example, it's altogether based, so it should be enough for a regular a common length. But if you want to do a multi 100K or even like the millions context lengths, I think you need to turn to the ring-based context parallel and see how to overlap the communications and the computations carefully for both the compressor and the attention. And I think for the entire IO system, you might need to consider like more different aspects, including the inference engine, how to solve with the long tail problems, because it's very like max continuous is very long, so it's hard to go to a truncation region. And maybe how do you do the workload balance across all the inference engines and training engines when you get a lot of the trajectories? How do you put them onto the training engines? There's a lot of issues to investigate.
Awesome. I think we can expect one more question from the community like before there's some more question coming. So I have one more question from my side. So this is for Cheng. So I know we have a cool book that basically we have the recipe to how to do the right thing. But like if like someone like he or she would like to to change the strategy a little bit, what's something that you will say don't do that?
Don't do that.
For example, like a TP, CP stuff, and like what strategy you just like don't do that for now.
For example, maybe someone expects to receive a huge decoding speed. They may use a large TP size to distribute the model storage, and which can sometimes increase the KV cache and eventually increases the concurrency. Yeah, this can be one scenario, but usually, according to our wait 1 minute. Yeah, that's a good design. Yes, it's a good choice. Yeah. So on the decoder side, you can always consider increasing the number of devices, or TB size plus DP size to plus DP size to maximize your throughput. But on the prefill side, because it is computer bounded, increasing TP size is not a good strategy. But for decoder side, because it's memory bounded, increasing the parallelism can amortize the memory loading, and it essentially improves the end-to-end. It essentially improves the decoding speed. So my comment, so maybe my answer here is do not tune or do not try to increase TP size for prefill.
This is great. Sorry for a weird question. I think we have one last question from the Slack community. Oh, actually, yeah, let's do the YouTube one first. Is there some sort of verification that can be done to make sure that this sort of bugs does not exist across the stack?
If you are asking SGLang, yes, we have a comprehensive unit test for each kernel and for our hybrid KV cache design. So if you can pass the OCI tests, we are mostly confident to ensure that the implementation is correct. And we also have a lot of accuracy tests to verify its end-to-end implementation.
I think Tom is referring to the fireworks article on malformed reasoning chain found on Day-0 implementation.
Yeah. Yes, that's a different issue because it's not an issue of SGLang implementation. We just follow the official because the DeepSeek released their reference code on Day-0, and then they quickly updated it, but we did not aware that at the first minute. So it's not incorrect implementation, it's some miscommunication between the DeepSeek team and the SGLang team.
I see. Yeah, and our team is working very hard, to make sure people can use DeepSeek on production during the weekend. And yeah, I think one last question that we can do is from Slack community. So someone asked, do we currently have high cache implementation on SGLang right now? If not, when would you support that?
We have supported high cache for DeepSeek-V4.
Okay. All right. I think that's it for today's Q&A. So let me quickly show you something about SGLang community. So if you had not, please scan this QR code, go to SGLang project. You can submit issue. You could observe the code and also talk to other people in the community. Please start us if you have not. Also, please follow LMC's Oregon X. So basically, all the Day-0 model support like DeepSeek and Gemma4, we're going to post that. Okay, and so again, we have a Luma calendar, and the link is the URL is luma.com/SGLang. So we're going to post all our physical meetup and also office hour like this to this calendar. So please subscribe, and you won't miss anything from us. All right, thank you so much. That's it. I also include a QR code so you can scan to join our Slack channel. Thank you so much, Cheng. Thank you so much, Yueming, for being here today. Thank you so much. See you next time.
Thank you.